Welcome to solving a simpler problem. So, a lot of the times, if we can, take something that's abstract and put a specific concept to it, it can give us insight as to how to solve an actual problem. So, we're just going to break these problems down and I'll kind of talk to you about some strategies that we might think about to solve the problems, and then we'll go through those. So, we'll just go ahead and go to the first one here. Now, it says, what day of the week is it 8,823 days after this Wednesday? Well, I don't know, but what I can tell you is this: 7 days after this Wednesday, it's going to be Wednesday, and similarly, 14 days after this Wednesday, it's also going to be Wednesday, and 21 days after this Wednesday, it's also going to be Wednesday, and 28. So these multiples of 7. So every 7 days, we know it's going to be Wednesday again. So if we divide this number 8,823 by 7, the remainder is going to be the number of days in addition is going to be from Wednesday, so we can count it that way. So the quotient is going to be the actual number of weeks, and the remainder is the additional days. So let's do this really quickly. So I'm going to do it out here. So 7 goes into 8,823. And notice I'm not using my calculator because then I'm going to get a decimal, which doesn't really help me now. 7 goes into 8 once. Put our 7 here. Subtract 1. Bring down our 8. 7 goes into 18. Twice, put our little 14 right there, subtract, we have 4, bring down our 2, 7 goes into 42, probably about 6 times, so 6 times that, we have a 42, subtract, 7 goes into 0 times, and we bring down the 3, and now we're good. So really, 8,823 days is the equivalent of 1,060 weeks. Well, 1,060 weeks from Wednesday, it's going to be Wednesday. So 3 is the remainder. That's the number of days after Wednesday it's going to be. 3 days after Wednesday, well, we got Thursday, Friday, Saturday. So 8,823 days after this Wednesday is going to be a Saturday. So again, because we're dividing by 7 the days in a week, the quotient is giving us the number of weeks. The remainder is giving us the remainder days. How many days are left over? And we get 3. Okay. Now, if we're going to find the sum of 200 even integers between 0 and 399. We're thinking about what is 0 plus 2 plus 4 plus 6 plus plus 394 plus 396. Let me erase here a second. Get out of there. Now it's no longer erasing. That's not cool. Now it's just moving around. Okay, so plus 398. So we look at this. So we're trying to find the sum of all these numbers. So one thing that we can do is this. If we're trying to find the sum of all of those numbers, we can... There was a guy named Gauss who's an old mathematician, and he figured out a way to do this. And what he did is he lined the numbers up like this. He wrote another copy of this. So we have 398 plus 396 plus 394 plus down here we have our 2 underneath our, there's 0 under 398, 2 under 396, and 4 under 394. Now, he didn't add them up horizontally, he added them up vertically. So if we add 0 to 398, that's 398. If you add 2 to 396, that's 398. If you add 4 to 394, that's 398. Now, you'll notice that if we keep adding these up, we're going to get a bunch of 398s. Now, notice it says find the sum of the first 200 digits. So we're trying to find the sum of the first 200 digits, so we're adding up 200 numbers here. So each of the numbers, when we add them vertically, is 398. We have 200 of those. So to find out how many we're going to have, I'm going to scroll down here to get some more space. Well, we have 398, and we have 200 of those, so times 200. The problem with that is that because we created the second row of numbers, that's exactly twice the actual sum here. So down here, our 398 times 200, if we divide that by 2, that is going to be the actual sum of 0 plus 2 plus 4 plus 6 plus 8 all the way up to our 398. So, when we do this, 2 goes into 200 100 times. 100 times 398 is just 39800, or 39,800. And that is the sum of those first 200 even digits. Now, the next one here is a minute problem, or an hour problem, which is going to be very similar to number 1 right here. So we can think about this. Now, it's currently 1:30 a.m. What time will it be in 759 hours? Well, 24 hours from 1:30 a.m., we know it's going to be 1:30 a.m. And 48 hours from 1:30 a.m., same thing. And we can keep playing that game. So really what we're going to do is we're going to divide our 759 by 24. Okay? So, now we're doing this. Now the quotient, what's up here, this is going to be how many days it's going to be. The remainder is how many leftover hours we have. So 24 goes into 75 3 times. And that's going to give us 72. Subtract here. We get 39. 24 goes into 39 1 time. 24. And when we subtract that off, we get 15. So the remainder is 15. So really, in 759 hours, that's 31 days and 15 hours. 31 days after 1:30 a.m., it's still 1:30 a.m. 15 hours after, though, well, 12 hours later, it'd be 1:30 p.m. Then we have 3 more, so we're talking about 4:30 p.m. That is the time of the day. So it really kind of follows the same logic as we have up here. Now, what time will it be in 10,382 minutes? Okay, well, same thing. We can divide the minutes by 60 to get hours. Then whatever, that's going to be the number of minutes later it is. Then we can divide the quotient, that is how many hours we have, by 24 to get that. So let's just take a look at this. We have 60 minutes in 1 hour. That goes into 10382. And now, I'm assuming you can do this. I'm going to do this just kind of on a calculator really quickly to save a little bit of time here. Not that I couldn't divide it. I probably could. I probably could. So, it's 173 hours, and there's a remainder of 2 minutes. So it's going to be 2 minutes later, but it's also going to be 173 hours. So we need to go back to this first thing and think about that. So we're dividing the number of hours by days to get that. So 24 goes into 173. And I'm going to do this once again. Not on here, I really don't have enough room, but also it saves time. Actually, 24 goes into 173 7 times. And we go 7, so 7 times 24 is going to give us 168. Subtract that off and borrow here to make that, and we get a 5. So really, 10,382 minutes is 7 days, 5 hours, and 2 minutes after whatever time it is. So we divide it by 60 to get the number of hours, and then the remainder was in minutes. Then we divided the number of hours that we had up here by 24 to get the number of days, the remainder in minutes. So 5 hours and 2 minutes after 1:30 a.m., we're looking at 6:32 a.m. So hopefully that kind of made some sense to you there, but it follows the same logic as we have on problem number 1. And I just did the calculations on a different piece of paper because my spacing for this is not great. So the last problem is this. There are 8 executives at a business meeting. Each executive must shake each other executive's hand exactly once. Now, it does state that me shaking your hand and you shaking my hand only counts as 1 shake. So how many total take place? So I draw a little picture, because I like pictures. So I get 1, 2, 3, 4, 5, 6, 7, 8. And think about it like this. The first person is going to shake 1, 2, 3, 4, 5, 6, 7 hands. Okay? Well, the next person here already shook the first person's hand, so they only have to do 1, 2, 3, 4, 5, 6. So plus 6. This next person's already shook the first 2 persons' hands, so we have 1, 2, 3, 4, 5, so plus 5. Next person right here has shook the first 3, so we have 1, 2, 3, 4, so plus 4. And you can probably guess the pattern is going to be the next person has 1, 2, 3, so plus 3, and then plus 2, and then finally plus 1. Okay, so it'd be easy enough to add these up, but let's use that technique we did in number 2 to find what this sum is. Now I'm going to line these numbers up. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. And notice, when we add vertically, we get 8, 8, 8. In fact, all of those are 8s. How many of those do we have? Well, 1, 2, 3, 4, 5, 6, 7 of those 8s. So we can think we're going to have 7 times 8. But because we have the 2 strings of number, we have to divide by 2. So divided by 2, 8. 2 goes into 8 4 times. 4 times 7 is 28. So there are 28 total handshakes at that meeting. So hopefully that made sense to you, and I'll see you back here for probability.